let us begin mechanical properties of fluids. Next chapter. In our last chapter, what did we discuss? We discussed about solids. How does the fluids differ from solids? That's the first question. Anyone? Solids के बारे में क्या बताया था हमने? Solids have definite shape and its size, right, or dimension. And what about fluid? Fluids has no definite shape of its own, right? Have no definite shape of its own. Suppose you have some water, right? If you put it in the glass, it will take the shape of a glass, right? You put it in some other utensil, it will take that shape. Yes or no? समझ रहे? But in case of solids, they have a very definite shape and some dimension. जैसे chair है, table है, they have a definite shape. Okay, solid. They come in the category of solids. Clear? Even a small shear stress can change the shape of a liquid. And many times, you know. Let's talk about pressure. So how do we define pressure? We already defined it in earlier discussion. Pressure is limit delta A tends to 0, delta F upon delta A. Okay. If there is a small surface area and you are putting a certain force delta F, then limiting value delta A tends to 0, then the ratio of delta F upon delta A represents the pressure. Pressure is a scalar quantity. So you should remember it is a scalar quantity. Okay. And what about dimension? Dimension of F क्या होता है? MLT minus 2 and area की dimension क्या होती है? L2. So final dimension क्या हो जाएंगी? ML minus 1 T minus 2. Got it? And what is SI unit? The unit is Newton per meter square. Okay. Another quantity that we would most oftenly used while dealing in this chapter with fluids will be density. Okay. The density is represented by rho and it will be equal to mass and its volume. Mass upon volume. You are already aware about it. M upon V. So ml minus 3 would be its dimension. Okay. रो, पी लिखेंगे तो ऐसे लिखेंगे। ओके, बहुत थोड़ा सा डिफरेंस है, ऊपर से ये इस टाइप से लिखेंगे। एट द सेम टाइम regarding pressure, let us try to do one question. The two thigh bones its name is also called femurs. Each of cross-sectional area 10 centimeter square. Each of cross-sectional area 10 centimeter square. Support the upper part of a human body. Human body of mass 40 kg. Of mass 40 kilogram. Right? Estimate the average pressure sustained by femurs. Estimate the average pressure sustained by the femurs. तो कैसे करें? कितनी एक थाई बोन्स है? दो है ना, राइट? और दोनों में से ईच क्रॉस सेक्शनल एरिया कितना है? 10 सेंटीमीटर स्क्वायर। सो टोटल क्रॉस सेक्शनल एरिया कितना हो जाएगा? बोलो। ट्वाइस हो जाएगा ना, 10 सेंटीमीटर स्क्वायर, तो कितना? 20 सेंटीमीटर स्क्वायर। यस, एग्रीड और नॉट? सो 20 सेंटीमीटर स्क्वायर को ऐसा यूनिट में कन्वर्ट करो, 20 इंटू 10 टू द पावर -2, 10 टू द पावर -2 मीटर स्क्वायर। ठीक है, एंड फोर्स या मास, कितना मास ये दोनों के दोनों थाइस जो हैं कितना मास कैरी कर रही हैं? 40 kg. So F can be said as mg, which is 40 times 10 Newton, 400 Newton. So P average, ऐसे P average लिखोगे F upon A, यहाँ पे A लिख लो, तो प्रेशर निकालोगे 400 न्यूटन अपॉन 20 टाइम्स 10 टू द पावर -4 मीटर स्क्वायर। सो आंसर क्या आया? 20 दूनी 40, सो 20, सो 20 टाइम्स 10 टू द पावर 4 न्यूटन पर मीटर स्क्वायर। ओके, सो फाइनली यू कैन राइट इट 10 टू द पावर 5, स्टैंडर्ड फॉर्म में लिखना है तो like this. So P average या pressure is calculated in this manner. Is all of you clear? Are all of you clear? We will discuss now Pascal's law. In the Pascal's law, we shall understand it through a let us take, this is a vessel and it has got certain liquid in it. Let us take one यहाँ पे हमने क्या किया है, लिक्विड डाला हुआ है. ओके, नाउ हियर इन द लिक्विड इफ यू सी, लेट मी टेक 3 सरफेसेस लेता हूँ मैं. कैसे लें? एक सरफेस तो हम ऐसे लेके दिखा सकते हैं, ऐसे, राइट. इसको थोड़ा सा डिफरेंट कलर से डाल दें तो ज़्यादा अच्छा रहेगा. हैं, ऐसे एक सरफेस ये होगी, दूसरी सरफेस को ऐसे ले सकते हैं, हाँ या ना, ये हैं, और तीसरी सरफेस को हम इसको ऐसे मिला सकते हैं. ऑल डन? ओके, यू कैन गो. ओके, ठीक है. कितनी सरफेस बनाई हमने? 3 सरफेसेस, राइट. एंड देन इसको हम नाम दे देते हैं ए, बी, सी, एंड देन डी, ई, एफ. And then if you see how the fluid is putting pressure, fluid puts pressure on these surfaces from all the direction, right? So we can say that the pressure is on this surface. Let us say this was point B, so I will call it FB. Okay, and then this surface is A, so I will call it FA, and then let this be FC, F of C. These are the forces that are actually being these forces are being experienced by these respective surfaces, right? Clear हो गया? So this figure looks like a prism if you see, isn't it? Now what exactly we are seeing? We are seeing that the Pascal's law says that if their respective areas are, let us say A, area of B surface and area of C surface, right, are the respective areas of 3 surface. Okay, then if you pay little attention, let us say that this angle could be some, and this angle would be certain angle. Let's say this is theta 1 and this is theta 2. Okay, so if you see, we could see f of c as fb sine theta, and then f of a would be fb cos theta, and a of b sine theta would actually give me AC, and AB cos theta would give me A of A. Simply by geometry, this is by geometry, आप देख सकते हो ना, और ये आपको मिल जाएंगे by equilibrium, by equilibrium. We can easily see that horizontal is given by cos theta, the vertical is given by sin theta. Yes or no? Clear है ना? that I had already taught you earlier. ठीक है ना? चलिए. So if I really take, then do you see f of b upon a of b is equal to f of c upon a of c is equal to f of a upon a of a. Did you notice that? आप करके देख सकते हो वैल्यू डाल के. So which means what? Which means P of B is equal to P of C is equal to P of A. That means pressure on all the surfaces is the same, you know, and this is what the Pascal's law is all about. Pascal's law says that if there is a body inside the liquid, from all direction it exerts the same pressure. The pressure amount on each surface is going to be same. So net pressure is going to be the same everywhere. Okay. So this is your. So we say that pressure exerted is same in all direction. Hence इसको लिख लेते हैं. Hence pressure exerted is same in all directions in a fluid at rest. Remember, in a fluid at rest. And this is called as Pascal's law, or known as okay. How does the pressure vary with depth? We will discuss. So the new topic is variation of pressure with depth. आइडियली डेप्थ बढ़ेगी, जैसे मान लो आप ओशन में जा रहे हो और नीचे जा रहे हो, उसके डेप्थ जैसे जैसे बढ़ेगी तो प्रेशर बढ़ना चाहिए या घटना चाहिए? बढ़ना चाहिए ना. सो लेट अस again try to understand what really happens here. So let us just say that again we are having a vessel, okay, and then let us take this. There is this liquid, and in this liquid there is this cylindrical column of height h, okay. Let us say this initial height is h1 and this whole height is h2. So what we are telling is that h is nothing but h2 minus h1, yes or no? Correct. Now let us say as a result of center mass acting on the center, mg is getting exerted as downward force, right? Okay. So what will be the total pressure? Let us say here the pressure is on this surface, the pressure felt on this surface is P1. Okay, let's take here is P1 and on this surface it is P2. Okay, so difference in the pressure would be what? P2 minus P1. This is what we are interested in knowing. Okay, on this surface here, at this surface we have got PA, atmospheric pressure, right? So, and if we just imagine that there is a liquid column over here also, yes, here. So this liquid column, what will be the mass of this liquid column? So P1 would be basically PA plus, we are interested in this knowing the entire volume. So volume will be what? Area multiplied by H1, that will be the volume, multiplied by the rho, that is rho of the liquid. Remember, rho is the density of the liquid, and then overall mass nikal aaya, then multiplied by G. Similarly, what will be P2? P2 will be PA plus A times H2 times rho times G, and the pressure difference, as we said, that P2 minus P1 would be PA plus rho GH2A minus PA minus rho GH1A. So we can cancel PA and we say rho GA H2 minus H1. Okay. So we are getting rho G and then A into H2 minus H1 is H. So actually if you see A H1 rho G is the total exertion of the force. So we have to know the pressure, we have to divide by area here also, area, and here also by area, correct? So A will get cancelled here. So what shall we see? We rather will not see any A over here. So let us just see that we can just remove this A, because we want to know the pressure. So what is this? We would say that it is rho G H2 minus H1, which is rho G H. So difference of the pressure between the two points would be rho GH or rho HG, whichever way you want to call it. If there is any doubt, please ask. Tell me, have you understood it? Here one more thing I want to tell you. Regardless of shape, let us say, suppose you have got a shape like this, and then this is a closure. Now you put a liquid over here. Let's say this is C, A, B. I put a liquid over here up till here like this. This is the liquid column. So you should be clear about knowing that your surface of the water would be same everywhere regardless of the shape. Okay, are you clear about this? Because the pressure at these points are same everywhere, so they will attain the same height regardless of the shape. Clear? So sometimes you may get an MCQ having different shapes. So you should be very clear as to how to answer such questions. Let us try to do a question. What is the pressure on a swimmer what is the pressure on a swimmer 10 meter below? The surface of a lake. Okay. So tell me. Take row of water. 1000 kilogram per meter cube. Standard. Okay. So let us answer. Rho 1000 kilogram per meter cube. Okay. H कितना है? 10 meters itself. So what will be the, अब देखिए यहाँ पे, if you see, here is the lake, the water is like that, so lake surface is there, lake surface. So the person is 10 meter below, below. So already there is a pressure here PA, yes or no? In addition to that you have MGH, yes, concept बोल रहा हूँ, ये समझ लो, सीधे सीधे MGH नहीं लगा सकते आप, because there is a atmospheric pressure plus MGH. So total pressure कितना हो जाएगा? You will see that my total pressure P is PA plus rho GH, like that. Now can you put the values and calculate? So what is your P? P will be PA plus rho GH. Atmospheric pressure को आप कितना ले सकते हो? You take 1.01, okay, into 10 to the power 5 न्यूटन पर मीटर स्क्वायर, या पास्कल भी लिख सकते हो आप, पास्कल प्लस रो कितना है 1000, जी को कितना ले लें 10 एंड एच को भी 10 ले लो. ऑल राइट. सो क्रिटिकली ये भी 10 टू द पावर 5 है, तो कॉमन ले लो 1.01 plus 1, so you will have an answer 2.01 into 10 to the power 5 Pascal. 1 Pascal is same as 1 Newton meter square, याद रखना, 1 Pascal is same as 1 Newton per meter square. So this is my pressure. Are you understanding this concept or not?
Sir, washroom चल जाऊँ?
Yeah, okay. There are other units. You can just note them. 1 torr is equal to 133 Pascal. So TOR, torr is also a unit of pressure measurement. That's why 1 torr is 133 Pascal. It's a very high amount of pressure. Torr. Torr is after the name of Mr. Torricelli. He was the one who devised this unit. Okay. And also there is 1 bar. bar is quite popular. 1 bar is 10 to the power 5 Pascal. Okay. ठीक है जी. Now let us try to write and solve a couple of problems. Let's say the density of the atmosphere at sea level, the density of atmosphere at sea level is 1.29 kilogram per meter cube. Assume that it does not change with altitude. Assume that it does not change with altitude. Then how high would the atmosphere extend? Then how high would the atmosphere ठीक है. Can you tell me how we can solve it? Already you know what is atmospheric pressure. What is that? 1.01 into 10 to the power 5, and let the column of atmosphere be height of h. Yes or no? Okay. And you take this as area को ले लो unit as 1, right? So क्या वैसे भी तो रो जी एच है ही है ना, आपको एरिया की वैसे भी जरूरत कहाँ है. रो टाइम्स जी टाइम्स एच, एच ही तो निकालना है. सो रो की वैल्यू 1.29 इंटू जी की वैल्यू 9.8 इंटू एच. So what will be the height of atmosphere? Typical height of atmosphere is 1.01 into 10 to the power 5 upon 1.29 multiplied by 9.8. Is that understood? So typically value of h would be 7989 meter, which is approximate. It can be approximated to what value? 8000 meter, or simply 8 kilometer. 8 kilometer. Yes or no? So based on the assumption that we have discussed, typically the height of atmosphere extends up to 8 kilometer. All right. So if you take the height of this Mount Everest, what is the height of Mount Everest? Do you know? It is 8848 meters, 8848 meters from sea level. Now you can imagine that there is no atmosphere there. That's why people have to carry their oxygen cylinders. Getting my point? Okay. एक क्वेश्चन आप लोग सोल्व करें. At a depth of 1000 meter, in an ocean, what is the absolute pressure? What is the absolute pressure? B, what is the gauge pressure? And C, find the force acting on the window of area. Find the force acting on the window of area 20 centimeter into 20 centimeter of the submarine, of a submarine at this depth. At this depth, the interior of which is maintained at sea level atmospheric pressure. The interior of which is maintained at sea level atmospheric pressure. At sea level atmospheric pressure. The density of seawater is, now the data, density of seawater is 1.03 into 10 to the power 3 kilogram per meter cube. Normal वाटर से थोड़ी सी ज़्यादा होती है. And take value of G as 10 meter per second square. Tell me, how will you tell the absolute pressure in A? Already I have discussed. Who will tell? हाँ जी, खन्ना जी आप बताइए. This is the surface. So I had already explained you the concept. Here it will be PA, and if you are at a height of H, so additional pressure would be rho GH. So it will be PA plus rho GH. That will be your absolute pressure. So why can't you people tell me? Discussion हो रहा है तो फिर तो then you should come forward ना. So this is your absolute pressure. Can you calculate for A what is absolute pressure P? Absolute pressure P is PA plus rho GH So calculate. PA is nothing but 1.01 into 10 to the power 5 plus rho. Rho is 1.03 into 10 to the power 3 into G. G is to be taken as 10 and height कितनी है below the surface? 1000 meter. So take 1000 meter. So how much this will become? 10 to the power 5 you can take as common. So and then you will get 1.01, and if you take this, so 100, so plus 103, so it's going to be 104. Here it will be 103 rather. So 104.1, 104.01. Okay, and you can again call it 10 to the power 5 Pascal. So the amount is 104 एटमॉस्फेरिक प्रेशर ATM ऐसा लिख सकते हैं अपन. P is this. So A की वैल्यू निकल गई. Okay. The gauge pressure. Now I will tell you how you calculate the gauge pressure. Here it is. This was PA, yes, and here at this point, which is 1000 meter down. So यहाँ पे gauge pressure निकालना तो क्या होगा? Gauge pressure होता है, gauge pressure is actually this net pressure rho GH, because it will be simply after deleting, that is यहाँ पे suppose P है, so P minus PA. Okay. So P minus PA हमने तुम्हें को ऑलरेडी बताया ही है कैसे निकालते हैं. So it is simply rho GH. Rho GH. तो रो कितना था? 1.03 into 10 to the power 3 multiplied by G is 10 into H is 1000 meter. So this was your, so this is 103 ATM. So this was your gauge pressure. So we will call this gauge pressure. Have you understood what is gauge pressure? The net pressure of that particular column of the liquid. Simply rho GH in that case, in this case. In question number C, what is asked? What is pressure outside the submarine? Pressure outside the submarine, it will be PA plus rho GH. I had already told you. Let's call it P. And pressure inside सबमरीन के अंदर प्रेशर कितना होता है? कितना होता है? एनी गेस? Inside the submarine is same as atmospheric pressure. Remember PA, है ना? Because हमारी बॉडी क्या चाहती है? एटमॉस्फेरिक प्रेशर, है ना, उतना ही होना चाहिए. कम ज्यादा होगा तो हमें दिक्कत होगी. So the net pressure acting on the window is gauge pressure. Hence, the net pressure acting on the window is the net pressure. तो net pressure कितना है? Net pressure is the gauge pressure. Window is the, we can say the net pressure is the gauge pressure. So GA UGE, ठीक है, gauge pressure. So we can say PG is rho GH. And since the area, since area of window कितना है? Area is 0.04 meter square, yes or no? So the force acting would be, force acting कितना होगा, पीजी multiplied by A, pressure into area, that would be the force. So Pg is rho gh, rho gh times A, तो वैल्यू रख दो, रो की वैल्यू 10, आई मीन गेज प्रेशर तो हम ऑलरेडी निकाल चुके हैं ना, तो पहले ही जो पहले वाला हमारा था गेज प्रेशर का उसका 103 था आई थिंक, सो 103 atm था, सो 103 टाइम्स 10 to the power 5 पास्कल इंटू 0.04 मीटर स्क्वायर, ये हो गया नहीं हो गया, ये वैल्यू हमने ऑलरेडी निकाल रखी है एज पार्ट ऑफ गेज प्रेशर पहले से, तो हमने सिंपली रिप्लेस कर दिया। सो ये कितना हो गया हमारा, ये हो गया 0.04 से मल्टीप्लाई करेंगे तो कितना आएगा 4.12 टाइम्स 10 to the power 5 न्यूटन। सो दिस इज द फोर्स एक्टिंग वुड बी, ऐसा लिख सकते हैं। So different if you know the concept you will always be able to solve the question. You should know what is gauge pressure, height, हाइट पे जो निकालेंगे डेप्थ पे निकालेंगे तो रो जी एच कैसे निकालेंगे, ये सारी चीजें हमें पता होनी चाहिए। यस और नो, सो वी शुड हैव टोटल क्लैरिटी ऑन दिस।